Today we'll be finally covering the intersection. So cars will be able to drive up, see if it's a red light or a green light for their specific lane, stop or continue going. And then when they go, they pick a random direction. So these both went straight this time. And this time around, one turned and one went straight. This, of course, won't cover absolutely everything of the intersections. It'll only get us started with it, but I think it's a good start. So let me show you how it's all set up. Here we are in the previous version of it where we had the car just going around in a loop. So now we need to set up intersections. For the intersections, I want to have a custom collision for them. So that way intersections can tuck with the intersection lanes without having anything else get in the way. And one way that's pretty easy to do that with is by setting up a custom object collision again, specifically for the intersections. That also would allow you to potentially find them all really quickly by just doing a big trace specifically for that. So to set that up, go under Edit, Project Settings. Then under Engine Collision here, we want to have a new object channel. So I've gone ahead and named it Traffic Intersections here, and I'm going to make it Ignore by default for everything. I want everything by default to ignore it, and we'll set up the ones that we need afterwards. So you can see here, we have now Traffic Road and Traffic Intersections, both default ignore. Perfect. And we're going to need to set up the intersection. So let's go ahead and just modify some of these paths here so we can have an intersection set up. Now I've gone ahead and set up 2 lanes here. This is for demonstration. It doesn't require to have a 2-lane wide per direction. This way I can have one lane go straight and right, and the other one maybe go straight and left, or just straight. We'll be able to control that. The main thing is we're getting the basic road setup for this testing. But with this, let's go ahead and set up the actual intersection. Here in the content browser, I'm going to right click, grab ourselves a blueprint class of a type actor. I'll call it BP Traffic Intersection, just like so. Then I'll just bring it out. It is not going to be much here, but we'll just put it in the world here and open it up. The main thing we're going to need here is a box collision. So we'll grab a box collision from the components. The box extent here entirely depends on the size of your intersections. I'll set mine to something like 1250 by 1250, and the height does not need to be that high, so 500 is plenty. If I go ahead and compile it, we can take a look. And the main thing we want to see is that the intersections are all going to go through it, and where we want to put the lanes is also going to go through it. Honestly, looking at this, either I need to move these closer, or chances are I need to make this intersection a bit bigger. So I've gone ahead and modified my bounds here, my box extents. They're now 1750 by 1750 by 500, because for how I laid it out, that is the better size. You can see here, we have plenty of room for the intersections and to have the lanes. One thing to always watch out for is this right lane. We don't want it super close. For example, we don't want these 2 lanes to be like this, because that means the actual turn radius will be basically a sharp 90-degree turn. By having this amount of room, you can think of it, this is the sidewalk. We're going to have at least some bit of curve here. While not necessarily this big, for these, this will do just fine. So now we need to line out the actual roads that's going to say, okay, this lane goes this way, this lane goes that way. How do these lanes go? And the reason I decided to do it this way, by the way, is because I did not like the idea of it done procedurally. If you're familiar with my CityGen series that I'm making this traffic system for, basically, right now we only have 2 lanes, one going one way, one going the other way. So it's very simple. One lane can just go to everywhere. But as soon as I start adding multiple lanes here, I might want to have a spot where even though there are 2 lanes in one direction, I only want them to turn right, even though there is a way going left. But let's say I want this to be a one-way only right turn section. Well, if it's procedural, how do I do that? That becomes very complicated. What if I also want the left turn lane to turn separately from every other lane? What if I want only the left turn lanes, then only the right turn lanes, then only the straight to go on one side? What if I have 5 directions? We have 5 intersections set up. You see how procedurally this starts to become kind of a mess? Yes, it could be done with some very advanced math and calculations, but then whatever you're using to spawn your intersections with also has to be using that system. And in my case, I'm setting up pre-made roads, pre-made intersections. So I know this lane is designed for this. I'm going to have decals here that show this is a left turn lane, so I'm going to make that a left turn lane. So because of all this, I am setting it up the way I am, a little bit more manually, but a lot more control. That doesn't mean it's the best way to do it or the only way to do it, just the way that fits me, I think, best. So with that in mind, what we're going to need is some splines for the intersection. Now we don't need to reinvent the wheel. We already have the road splines, so we're just going to reuse them, but I'm going to right click on them and create a child blueprint class. This is going to be a road spline instead of child, a road spline intersection. So pretty much the same thing, but it's an intersection. I'll go ahead and double click to open it up. And here's the intersection. And The main things I'm going to change here are on the spline. I'm going to scroll down, and in the editor here, I'm going to change the spline unselected color from green to blue, just so we have a visual difference. So at a quick glance, I can tell which one is which. And I'm also going to add two variables here. The first one I'm going to call stop at intersection, which is just a type boolean. And the second one is the light number, which is just going to be an integer. The light number does need to be exposed, so we're going to hit the eye icon here. And what are these for? Stop at intersection. If it is on, the car is going to check for it and say, hey, I need to stop here. It is a red light effectively. If it is false, then cool, I'm not stopping, I'm going, all good. And the light number will allow us to control the order of the lights in the traffic system. So if we want left turn only to go first, we can. Straight then, we can, etc. It doesn't cover 100% of every situation with this, but it covers most common ones. So now how does this work? Well, all we do is grab this road spline intersection, drag it out. Now you want to make sure it starts from within the bounds of this volume, and you want to make sure it's going to line up right with the original spline here. So something like this. So this one, I'm going to want an option to go straight through. You don't need to stop anywhere. Well, same thing with the other one. I'm going to want this one to also go all the way across. Okay, cool. But this is only straight. Now, what if I want this right lane to either go straight or turn right into this lane? Well, all we need to do is in the detail panel here, we need to add ourselves a new spline component. So we'll just hit add and search for spline, grab ourselves a spline component, and now we have a spline one that we can just take and move right over here, rotate it accordingly, and then position it as well as the original spot here. And then we can just adjust this curve. And basically, as you can see, we're making a second spline component here that now says, hey, straight or turn into this right lane. We can also give it the option of turning into that second lane. So same thing, we'll add another spline, go and add it, click on the point, scooch it over, rotate it, and line it up, maybe extend this a little bit. And if you want to get to the first point, by the way, and you're struggling to click on it because they are overlapping right now, in the detail panel here, you could click on this one, select the first spline point, and there you go, it is selected. So now you can go ahead and rotate it and get this line up, and again, just move your points around like so. So now you can see it is going this way, or straight. Cool. For demonstration, honestly, I'm not going to have this one go straight. I'm going to have this one only turn left. So now we can have just the left turn lanes go first so they don't hit each other. And then we go from the other. So same thing as before. We go ahead and just set this up, adjust the curves. Again, to select the first one, since it's the only one, we can just select it, rotate it, and adjust this curve a bit. So let's say we're happy with this. I want to do the same thing on the other side. So we'll just take it, hold Alt and rotate it so we get a copy of it and line it up with the other one. Again, we want to make sure that it lines up inside of the bounds, but just move this a little bit. And that looks pretty good. So these two left lanes, I want them to turn first, because otherwise, right, if this one has a car coming straight and this is a left turn lane and both of these are green at the same time, we're going to run into an issue where the cars might hit each other, and we don't really want that. So that's where that light number comes in. I'm going to select both of my left turn lanes, and then here in the light number, I'm going to make a note. This is light number 0, okay? It always starts at 0 because we're going to be using an array. Array starts at 0. So that means that the other two lanes, the one that potentially turn right or go straight, are going to be light number 1. Okay, so we have that. It's going to go left turn for these, left turn for the opposite directions, then right turn or straight for the other lane. Cool. That is only for this one direction. We also need the other one. So I can go ahead and select all of them, hold Alt, rotate them all, and then we'll go ahead and position them for this. Now, again, we need to adjust the lights. I'm going to select the two left turns, and I want them to go next. So it's going to go left, left on the opposite side, straight. And then now it's the other side's turn, the other two intersections. I want them first to go left, then go straight. This is also the point where I can say, hey, there is no left turn on this way. I can just say, okay, all of them are going straight, all of them at the same time. In fact, for demonstration, let's do that. I'm going to remove this left turn lane and this left turn lane. I'm going to have one straight one here and another straight one in the other way. So this way does not have any left turns. This way does. And because of there is no left turns here, we can have all of these go at the same time. So I'll select all 4 of these. You can see the outliner here, 5, 6, 7, 8, light number 3. I want them all to be in the same place. Now, one thing to notice is I just moved it and hit Control Z, and this is staying here. That's a problem. It's easily fixed if I just slightly move, but if I undo, right, it has issues. So once everything is lined up, we're good. And for the time being, the lanes are not perfectly lined up, at least for the intersection. So what I'm going to do is give it a little more leeway to the cars to detect which one it actually sees and when it's close enough to get assigned this lane. All we need to do is select one of the cars and then come here to the event graph where we had the set current spline component. Right here, it's checking against the speed compared to the current frame rate, so that way it barely moves. I'm going to add a new pin here. I'm just going to increase the distance at which it's fine. Let's say to 2. So it's not much bigger, but it's a little bit bigger. And now if we take a look and we have these two cars go with just a little bit more, you'll see they'll slightly snap here, but there we go. This one went to the second lane and then continued on. This one went here, of course, because it's the only way it has. It only has the left lane. If I have it run one more time, it's going to again randomize one of these three. So let's see where it goes. This time it went straight. One more time, just to show that it is random. And oh, we got the last one actually. Convenient. So now we have the cars being able to pick a random lane and go that way. Cool. Let's actually set up the intersection logic now. The first thing for that, we're going to modify this box collision and the collisions for it actually. So in the detail panel here, we're going to search for collision and we're going to change the collision preset from overlay all dynamic to custom. Now I'm going to say ignore everything by default and change this object type for world dynamic to traffic intersection. It is an intersection, so I want it to be the object type traffic intersection. I'm also going to turn vehicle to overlap and traffic road to overlap. So if we need to, we can have this check overlaps between these or return overlaps between these. Now, it's great that this can detect the traffic lanes now, but the intersections can't. So I'm going to open up the BP intersection spline, go into its box collision. I'm going to scroll down to its collisions and change traffic intersections to overlap here as well, because I wanted to listen to the intersections. Now, you can't do this in the parent, so they all listen to it. I just care only about the intersections one listening to it, so that's why I'm only having it do this. In case I have another spline going through the intersection above or below that's just a regular road, but is not necessarily an intersection, I don't want to deal with the headache of potentially grabbing something it shouldn't. So great, now going back to the BP traffic intersections, we can close out of this collision section, go to the event graph, and get started. The first thing we need to do is get rid of this event tick and begin overlap. We're not using it. We're only doing everything on begin play. And the first thing we need to know is for this intersection, wherever it is in the world, what are all of the traffic lanes of this intersection that we need? So we need to grab them all. So what I'm going to do is right click and search for get overlapping actors. I only wanted to check itself. And the class that we're overlapping is this BP road spline intersection. As long as this spline is overlapping, how many of them are there and what are they? I want to know. So with that, I can just drag out and do a for each loop. So right when you begin play, hey, grab everything you need. I'm going to have to save a bunch of variables. I also want to save the index. I don't want to do that in this event graph because they're going to be global. So I'm going to right click, collapse all of this to function. I'm going to rename the function get lane traffic lights. So I'll just rename it to that. And now I'll double click it to open it up and continue in here. Because now I can right click on this array element and promote it to a local variable. I'll name it something like current spline reference. So that way I don't have to drag it out for the other stuff we're doing. But basically, how is this going to work? We're going to go through and we're going to look at its light number or your traffic light number. I'm going to make a note. I'm going to save it all in a map variable. So I'm going to have the traffic light and all of the actual splines that correspond to it. So that way, later on, I could say, hey, all of these that are 0, you go first. Then the next ones, then the next ones, then the next ones. And I'm pretty sure it should work multiplayer as well, despite using a map, because it's not checking anything that is dynamically changing. It is always consistent. It's always grabbing the same information because it's always overlapping the same information. So I'm pretty sure this should work fine even for multiplayer. Just don't quote me on that because I can't check. But now that we have this current spline reference, I can just drag out of here and search for get light number. Okay, so now we have a light number, and now we can check if it exists. So for that, of course, we need a new variable. So we'll go ahead and add a new variable. I'll call this intersection lanes. I'm going to change the type here to be an integer because the light numbers are integers. And then I'm going to go in the detail panel. I'm going to hit this drop down. I'm going to change it to a map. Now, I don't want integer to integer. I want integer. And the second one here is those BP road spline intersection object references. But here's the thing. This will allow us to save 1 with 1. And we have potentially multiple lanes. So I need that to be an array, not a single. Unfortunately, it doesn't support arrays in maps unless you make it a struct. Because you can put a struct in the map and the struct can hold an array. See where I'm going with this? So now here in the content browser again, I'm going to make a new folder. I'll just call it structs. And here I'm going to right click, go here under blueprint and structure down in the bottom. I'll just call it something like s_traffic intersection array, just like so. I'll go open it up. And in here, all we're going to do, call it traffic intersections and change this variable type to our BP road spline intersection object reference. And then change this to an array. We only need the one variable in here. It's just going to be an array. It's perfect. So now back here in the BPE traffic intersection, for the intersection lanes, instead of this one, we're going to make it the struct. So I'm going to s underscore traffic, and there's our s traffic intersection array. Perfect. If I go ahead and compile, you'll see there's our intersection lanes, and we can add as many as we want over here. So the actual number of the traffic light has to be unique, but we can add as many actual splines here as we want. We'll go and clear this out, but awesome, this is working. So now we can go ahead and grab this variable and then see if we can find this light number inside of it. Hey, do we already have something stored under this? Because if we do, we just need to add it to it. Otherwise, we need to add a new one. So we'll just do a branch of whether or not it found it. If this is the first one of that light number, I want to add it to this map. So I'll go ahead and take this map over here, and I'm going to use an add. And a map add is not like an array add. When you do an add for a map, it is both adding a new one and overriding an existent. So instead of doing a map set, you have to do a map add. Don't ask me why. I also find this very confusing. I'm used to it now, but why it can't be just a set as well for maps, I couldn't tell you. So from false here, we're just going to this add, light number goes in here, and this is our struct. So we're going to grab our current spline reference here. We can drag it out from the variables, and we need to set this. So drag out of the struct and search for make s traffic intersection array. It's just down below here. So here we get the option of creating the traffic intersections, and we just need to make an array of this one single spline, because this is the first one. So if it does not find it, go ahead and make a new one with this light number with just one spline in there. Cool. If it does find it, then we do something different. Because if it does find it, we need to add to the array here. So I need to break this struct here, so we get this array, and then I need to save it locally, because this is a copy, this isn't a reference to it. And I'll call this struct array, just something simple. And when this is true, go ahead and set the struct array with the one we found. And then to this array, we can go ahead and add the current spline reference that we're doing on this loop. So I'm going to copy it here and plug it in. Now again, this is not part of the map. This is part of this local setup here. So we now need to add it to the actual map, or rather save it back onto itself. So what I'm going to do is grab all of this, copy it, paste it over here. And now after this add, we'll just drag it all the way to another add, because like I mentioned, we're adding it, but really we're just setting it with this new value. And instead of this current spline ref make array, we're using this struct array. So I'll grab it from the variables here and just plug it all the way through, because this one has this new spline. And now we just need the light number, which we can grab here the same way. So from this current spline reference, drag out get light number, and this light number is what we're plugging in here. So if we don't find it, go ahead and make a new array with it. And if we did find it, check the current array, add to it, and set it back to the map. So once we're done, we have a full map with every single spline under which light number it is. And now we set up how long do we want the actual traffic lights to take on each of these setups. Right now, it's all going to be the same amount of time. Down the line, we can go ahead and add a timer. So it'll go first one duration, then another duration. For now, that's fine. So what we'll do is just drag out and do a set timer by event. Let's say every 4 seconds, I want it to change. I'm going to loop it, and I'm going to tell it to do max once per frame, because there's no reason to do it multiple times a frame. And then from this event, we can just drag out, do a custom event, and call this next traffic light. Now, one thing to note is it will not automatically trigger this next traffic light the first time it does this. If I open this, it says initial start delay 0, but that does not mean that it starts at 0 and then again at 4. It will only trigger at 4 if we left it like this. So what we need to do is drag out of this timer and execute the next traffic light here. So that way at 0 time, it will do this. Okay, so we now have it being able to do something on a timer. So what we need to do is 2 things. We need to tell that the current one that is on green light to turn red, and the next one over to turn green, and let the cars through. Tell it that, hey, we can go ahead and, well, go. So from this next traffic light, we'll just do a sequence. We'll split this up, make it nice and simple, and we'll set it up with the drive one first. So the first thing I'm going to do is just say, hey, the current traffic light, grab me all of those. Grab me all of the lanes, and we're going to do something with them. So we're going to need this intersection lanes, but we're also going to need another variable called current traffic light. This is going to be just a simple integer. It is not going to be a map. So in the detail panel, I'm going to set it to be a single. And now I can grab this intersection lanes, drag it out, and drag out the current traffic light and say, hey, go ahead and find me the ones that are corresponding to this traffic light of index 0. By default, 0 is the first one you have, so you should always have a 0. But once you have that, go ahead and just break this struct so we can get access to this array. So once we have the array, we could say, hey, for each of these splines, because we know we're going to have at least one of these, let's do some stuff. So the first thing we're going to do here is just drag out and do a set stop at intersection. Because I want to make sure, because this is the drive one, do not stop at this intersection. This is a green light. This is our drive. Don't stop at the intersection. Now, to visualize this, I found it easy to do a drug debug sphere. This will allow us to just make a nice green sphere here that is going to be 4 seconds long, let's say with 4 thickness so we can really see it, and something like 150 radius. The location of this is going to be this array elements, this spline's box collision. So I'm going to search for get box because that is the name of it. It's just called box, and all the way at the bottom under variables, default get box, we can get it, drag out of it, and then get world location, because that is the start of our actual lane for the intersection. So using this world location, that'll go into the center here. So fantastic. And now at this point, we're going to say, hey, any car that's currently stopped there, go please. I can drag out and just search for a sphere trace for objects. We don't need a multi, we just need a singular one, because at most it'll be overlapping one car. The start and end here will be this box's world location. So I'll just go ahead and plug that in. So I'll plug it into the start and end and just organize it a little bit. The radius here is, let's say 150. This entirely depends on the size of your lanes, by the way, because keep in mind it's a radius, not a diameter. So if the size of your lane is 350, then 150 is safe because it won't go into the side lanes by accident. So adjust this number bigger or smaller depending on the size of your lanes, and you should be fine. Now the object type here, I need to make array and specify that I want it to overlap vehicles. Now here's the thing, this is all great, but we haven't set up the car to overlap with this. So let's quickly do that. Here we are in the car blueprint, and all I'm going to do is add a box collision to this as well. Simple box collision, and I'm going to change the box extents on this guy, and I'm also going to make it a little bit forward as well, and I'm going to do something like this. Let's say 300 on these X, 100 in Y. The height doesn't matter, so it's fine keeping it like this. Yeah, that seems good to me. The main thing we're using this for is the collision, because I don't want to use the car's collisions. There's no reason for it. We can just use a simple box. All we need to do is go into the collision of it in the detail panel, go to custom, change the object type here to a vehicle, and make everything ignored. And I only wanted to listen to other vehicles and the traffic road. Only those two will go to overlap. So that way, if we want to have another vehicle detected, we can, and the road will be able to actually trace to us, so the intersections will be able to communicate. So with that, we can go back to our BP traffic intersections, and this will now be successful. So from here, we can go and do a break hit result, open it up, and then say hit actor cast to BP car base. So we can go ahead and run the actual drive function on here. So we'll do the regular drive. That is the one that is going to restart the actual full timer. Now we haven't done the stop yet, so don't worry, we'll be stopping the timer when we're stopped, but this is good. And by the way, yes, you can do a interface here, but right now this is just fine. 1, because we're very early on, and 2, this is already the parent of every single car we're going to have. Whenever we're going to have this traffic system, we're obviously going to have the cars. So they're always going to be loaded at the same time anyway. So it's not a big deal. If you know Blueprint interfaces, you can set it up for yourself, and we might do that down the line. But this is the section for drive. So we're going to just comment it. I'll call it drive, and I'll make it green for go. So cool. Now we need to do the other way. If we have a red light, well, the first thing is we just went and said this is the green. So go ahead and grab the current traffic light and increment it so it's the next one. So now we're working with the following one. But when we increment it, we don't know if it is too high of a number. So go ahead and check if it is equal to the intersection lane's length. By just grabbing the length of the map, we can say if it is equal. Because if it is equal, that means it has gone too far. The length of this starts at 1, not at 0. When the index is equal to the length, that means you're 1 over the max. So when you are 1 over the max, you want to go back to 0. So when this is true, we can go ahead and use a branch and then set the current traffic light to 0. And then we can do the same thing as we were doing here. So I'll just go ahead and grab this and grab all the way to the stop intersections and the draw debug sphere, copy all this, paste it in here, drag it through. And this one, we're going to say, yes, stop at the intersection. And we're going to change the line color here to be red because it is stopping. It is not going. So this whole thing, I'll just call it stop and I'll comment it to be red because, well, it's red for stop. By the way, some of you guys might have noticed my little issue that I created before. Make sure under false, you're also continuing over, not just through true, just like so. So, okay, cool. This is pretty good. Let's see what happens already. So if I go ahead and simulate now, we can take a look. You can see there's the greens and it turned green right at the last moment. So let's play around with the timing. First of all, let's make the duration here to be something like 6. And because we're using these draw debug spheres, I want the duration of this to always match. So I'm going to right click on this time, promote it to a variable. I'm calling it traffic light duration. And then we can go ahead and grab it and plug it into the draw debug spheres for the duration. So if we ever change one, we can go ahead and just change it for all of them. So now that it's 6, it will automatically adjust for all of them. And now we can go ahead and preview it. So this is green and you can see this one went as well. Now, why did it go? Well, on this car, we're not actually telling it to use the stop at intersection yet. So let's go into the event graph and we want to go inside of this drive forward function. So let's go open up the drive forward. And here we are checking that once we run out here, we disable the spline. That's great. But what happens if we hit the intersection? So when we're on the current spline, I want to be checking in front of me and seeing, hey, is there a new intersection? So what I'm going to do is this trace for new path. We have this trace going. It's great. We're going to be reusing a bit of this. So I'm going to duplicate this trace for new path. I'm going to rename it to trace for intersection because there are a few things we need to change on this intersection one. Unlike when we're normally driving and we just need to trace forward, when we're following a spline, I wanted to check the position ahead on the spline. Because otherwise you might run into a position where for some reason you have one line intersection the other and there's another point, let's say here, or better yet, when it's turning here, it's going to turn and then straight ahead, right? You're going to have this guy and then it's going to get confused because relative to the turn of the car, straight ahead is another intersection and it's going to get a sign and it's going to have a bad time. So instead what we need to do is just check along this spline, whatever one it's following. And then if it is checking way too far ahead and it is checking the last point here, it obviously can't check past that. So at that point, we'll have it check just ahead relative to that last point. Once I have it set up, it'll make more sense visually. Back on the drive forward, we're going to be using something similar here. So what I'm going to do is just grab all of this and I'm going to collapse all of this to a function. So I'm going to right click, collapse to function. I'm going to call it get future position and rotation along spline. I'm going to open it and we're going to change just a few things. First, I'm going to change the returns. Instead of return value, I'm going to call it location. And the other one is going to be rotation. I'm also going to expose a variable here. I'm going to add a pin to the speed and get frame rate. I'm going to add a new input here. So I'm going to hit plus here, change the variable type to a float. I'm calling it relative speed mult. So a relative speed multiplier. I'm going to right click then and get relative speed mult and plug that into here. Now by default, this is 0. We don't want that to be 0. So what you could do is open up this input here with the input selected and we can change the default value to be 1. So that way nothing is messed up. But the other thing is we're not doing any kind of executable here. We're just getting values and multiplying them. So we can change this to a pure function. And then let's go ahead and compile. And then once we go back here, you can see there's our little get future position and rotation along spline. Cool. This is all we need in this drive forward section. But now we can go ahead and reuse it in this trace for intersection. So I'll put it in here. And the reason we expose this relative speed multiplier is so we can go ahead and scale it. So for this one, I'm going to scale it pretty high, 50, just so we can see it really clearly. So now we need to check if we are near the end. Well, again, on the drive forward, we're doing this check already. Current follow spline, get number of points. There it is. So we just need to grab all of this, copy it, and paste in here. And we're again comparing it to this location. But I wanted to have this check be a little bit closer because we know the location we're checking against isn't the actor's location. It is actually on the spline. So we can have this be a lot smaller. 5 will do just fine. So pretty much when we're at the end, then do something. And the end is just going to change what we plug into at the end here. So I'm actually going to remove all of this for the start and end. And from the current end, I'm going to do a regular select here. If you're wondering why I don't do a select vector, by the way, because it is a Boolean in either case, because we can plug this in here, is because this one does A, B, and says pick A, and this one just does true or false. So since I'm plugging things in anyway, my stupid brain is a lot better. Assuming I plug this in here, you can see it becomes the same pretty much. My brain is easier, like, oh, this is true, this is false. I'm like, A, B, we're picking A, so A is true. When this is true, it's picking A. Right? Like, my brain just doesn't like this. My brain really likes, oh, it's a true-false thing. Okay, easy. You can use, of course, whichever one you want. One of them just really clicks well with me, and the other one just makes me pause for just a moment, and I don't like that. So if we are at the end, or rather not at the end, we're going to be using the location in the future position. But if we are at the end, I want to get the rotation of that last point and project it forward. So I'm going to take this rotation, drag out, and search for get forward vector. So we're converting the rotation of the last point to a vector, and then we're going to multiply it by a distance. I'm going to right click and convert this to a float. I'm going to say, hey, check 500 units ahead if we're checking the last point. And then say, hey, whatever that distance is, add it to the current one. So we'll just do an add it to the current location, and that is our true. So if we're not at the end, we're using the current location that is on the spline. If we are at the end, we're taking and tracing past the spline 500 units relative to that spline's directionality. So cool. That is all we kind of need for the end. For the start, though, we're just taking the location here. This regular location. In fact, I'll just do a little bit of a cleanup here by just reorganizing this and clean this up a little bit. So there you go. So it's going from the location to the start, no matter what. Let's see what this is doing actually. So I'll go ahead and just say for duration here, so you can really see it. And I'll go ahead and detach everything past this sphere trace. But of course, for this to work, we need to set it up in the drive forward. So after this set actor location and rotation, we're going to do the trace for intersection. So let's take a look, play, and there you go. It is checking, and you can see it was going forward, and then it hit it here, and it found it. Fantastic. This one didn't, because it seems like this car actually on the right didn't actually get onto the track because it was a little bit too far off. Let's try again. There we go. So now they're both checking, and they're both finding that intersection. From the hit actor, we need to drag out and cast to BP road spline intersection. So we're now casting to the intersection because we need to get the stop at intersection that it has. Again, we can set up a blueprint interface later. For now, though, it's fine. There will always be this in memory because it's always going to be running since the cars are always going to be there and the traffic is always going to be there. So it's not a scenario where, oh, maybe it will never be loaded at the same time. We're loading something unnecessary. It's always loaded. But again, we'll probably set up with interfaces later if we need to. So if this is true or false, it doesn't matter. We need to store this information locally. So I'm going to right click at stop at intersection and promote to a variable. I'll call it the same stop at intersection. That is fine. So after the cast, assuming it succeeded, stop at the intersection, we store it, and then we do something based on whether or not it succeeds. If it succeeds, we wanted to do stop car, but of course we don't have that yet. So in the event graph, let's come over here and do a custom event. I'll call this stop car. I'm not going to plug it in just yet. We're just going to say off of true, stop car, and then go ahead and set the current spline component because we just found the spline that we need to get to. And of course, don't forget to actually plug in the sphere trace all the way through. Kind of important. So from the stop car, we can just do a print string and we can take a look at what happens. So coming up here, we'll say go, and they're just going to go as they were doing before. It's going to get that information, but you'll see that, hey, they're all going. Why is they all going? That's because on this road intersection blueprint, our stop at intersection is false by default. That needs to be true. By default, make sure that every single lane says stop. So that way we can one at a time turn them on and turn the previous one off. So there we go. Let's do that. And now if we take a look and we simulate and we take a look at what's happening, there's a bunch of hellos as one of them was set to be stopped. So awesome. We know one of them is saying stop and one of them is saying go. So now let's set up this stop car. I want to decelerate when we get to the intersection. I don't want a sudden stop. So for that, we're going to need a timer. So we're going to drag out and do a set timer by event. We're going to say 0.1 on the timer. We're going to make it loop. So it's going to adjust the speed 10 times a second. That is plenty for us. You can adjust this more or less, of course. And then from the event, I'll drag out and do a custom event and call it deceleration. Now, for deceleration, we need to know the current speed. Now, we have regular speed, but not current or max. So I'm going to change the speed variable to be called max speed, and we'll add a new variable that's called current speed. It is, of course, going to be of a type float. So now when it's decelerating, we're going to be setting this current speed using some math, some simple math though. So first we need to square the max speed. So basically we just need to multiply the max speed by the max speed. Then we divide it by twice the deceleration distance. So we need a new variable again. I'll call this deceleration distance. I'm going to compile it and give it a value of 100 by default. So then I take the deceleration distance and multiply it by 2. And this goes into the divide here. All of this needs to be multiplied then by this time. So I then multiply it all by 0.1. So it only updates as much as it needs to based on this time. And we take the current speed and subtract this number. Current speed, subtract u, and that goes into the new current speed. It's okay, so we're slowing down, but we need to tell it when to stop. So when the current speed is less or equal to 0, that means we are done. We're done here. So if this is true, we can drag out of this set timer and just search for clear and invalidate timer by handle. We just do not have it attached here. Instead, it is going off of this true. So we'll go ahead and stop this timer when it has reached the end. And of course, it also needs to stop driving. So this drive forward timer, right? This whole drive event needs to stop. So I'll grab the drive forward timer and also do another clear and invalidate timer by handle. So it will stop driving forward. Now this is great. You can comment and call stop car, but we're not using this current speed actually yet. So since we're going ahead and decelerating, we might as well set up acceleration. So that way we can accelerate to the speed we need to. So after this drive car, let's go and set up acceleration. So just like the other one, we're going to need a timer by event. Again, 0.1 seconds, looping. We'll drag out and do a custom event. And this one will be called acceleration. This one's going to be a little bit simpler. All it's going to do is take the current speed and of course set the current speed later. So current speed plus the speed that we want to accelerate by. So we need a new variable. I'm going to call it acceleration per second. And I'm going to compile it and tell it to accelerate 500 units per second. So then I take the acceleration per second and multiply it by the timer. So again, 0.1. If your timer is different, adjust accordingly, plug that in, and that is our new current speed. Nice and simple. So if this is greater or equal to the actual max speed that we have, then we throw in a branch and make sure that we did not go over by setting the current speed to be the max speed. This way, if it got increased a little bit past the max, it makes sure that it's hard capped at the max. And then when this is done, we can go and clear and invalidate timer by handle and plug this through just like so. Now in this case, we don't need to stop the driving because we're still driving, but we just need to stop the acceleration. So go ahead and comment this acceleration. Now this is great, but there are some other places we need to adjust, like the set current spline component is going off of max speed. We don't want to go max speed anymore. We want to go off of current speed. So we're going to change this for current speed because if we're going slower, we need to check further. Also in the drive forward here, again, max speed needs to be swapped for current speed. Same thing inside of this get future position and rotation, right? We have max speed that needs to be swapped for current speed. Pretty much everywhere we're using max speed before needs to be swapped for current speed. Easy way of checking, by the way, is if you right click on max speed, you can do find reference by name, and then you can double click on it to see where you were using it. We want to keep it on the deceleration and the places where we just set it up. But for example, this trace for new path, yeah, we need the current speed on this one instead of the max speed. Okay, let's go ahead and simulate and see what happens. So here they're going, and then one went and one stopped, and there you go. The other light turned green, and as soon as it did, one of the cars went. So once more time, I'll simulate, see what happens. This is still green. This one was red. Now it just turned green, and it's going now in this lane. So there we go. We now have two cars going ahead. One continues on because it's a green light, and the other one wastes and then continues forward. And we can go ahead and take these and put them over here as well. So we can see what happens when we have these opposite directions. And before I test this, I did realize that the light number I said here was 3. It was supposed to be 2 because we have 0, 1, and 2. Very important to have this in order. So now let's go ahead and take a look and see what happens. So if we continue on here, one of them is green, the other one stopped. Then we can see here, this one is going. And then after that, it should turn green for the other ones. And there they go. One turned right, one went straight, and there it is. They're going to continue on in infinity afterwards. Now, this is still just the basic actual system. I even threw in the acceleration, deceleration in there because it was easier to set it up now versus having to set it up later, because it would require us to kind of change some stuff. So I decided to, you know what, slightly longer video today, but hopefully it was worth it for you guys. Still a lot to do and figure out and set up in this traffic system. And I'm curious, what do you guys actually want to see next in the traffic system? I have my plans, but I'm curious, what things do you value the most in the system and things that you are most interested in? In the meantime, though, the project file for this will be available on my Patreon, where you can join these wonderful people here in supporting what I do. It really means a lot. And if you'd like to join the community, the Discord and everything will be down below as always. And if you're curious how it compares to setting it up with the Matrix demo one, I did do a video kind of doing the very basics of it, which you can check out right over here to maybe get inspired by things to come on this series.